Hello and welcome to our webinar CFA Level 1. We're talking about quantitative methods. We're talking about probability theory. My name is Daniel Lambert. I'm from Berlin, Germany, and I want to help you preparing for your CFA Level 1 exam. So this is what we're going to do. This is what we're going to talk about in this webinar. We're talking about probability concepts. We're talking about probability concepts. I just want to make sure again that you can see everything I write. Let's see. Dun, dun, dun. This is here, this is there. Okay, now I think you can see this, the probability concepts. You can see my mind maps. The mind maps will be created for CFA candidates for CFA Level 1 as well as for CFA Level 2. We'll be talking about terms now. We'll be talking about terms dealing with probability theory. For example, we are talking about events. We'll learn what events are. We'll be dealing with probability. We'll be talking about Bayes formula and so on and so on. So, and what we'll be dealing with as well is this. Let's take a look. Like this could be your CFA question. This could be your CFA Level 1 question. I just copied five or so questions. So now, first, let's take a look here again at the mind map. Talk about events, exhaustive events. If we have two events and the probability that let's take a look here. Can you see this? Yes, I think so. I think so. Let's write it down. I want you to understand. I want you to see everything I am writing. And no. For example, the probability of A and the probability of two events, A and B, at the same time, taking place at the same time is this. The probability of A as well as B. So A and B happen together. A and B happen at the same time. And so now it means that if we consider this to be A, and if we consider this to be B, this is the set A and B. This is the set A and B. And exhaustive means that every single event is said to be possible. Like if the probability of a given event is 1, so it means that given finite sets only, there is a possibility of 1 that any given event can happen. So this means that it's going to be exhaustive. That was the first thing for you to know. Mutually exclusive is a different thing. Mutually exclusive is this. Mutually exclusive is if we look at A and if we look at B, this means that A and B happening at the same time, A as well as B, is the empty set. So that means that A and B are disjoint. They cannot happen together. They cannot happen at the same time, meaning disjoint, meaning that there is no such thing as to B and A happening at the same time. Mutually, what did I say? Mutually exclusive. Dependent and independent. What is this? Dependent and independent. There is something to consider, something to calculate. A and B are independent from one another. If A and B, say A and B, is the multiplication of the probability of A and the probability of B happening together. So the probability of A and B happening together is the multiplication of the probability of A and the one of B. So if this is true, if this holds true, then A and B are said to be independent. A and B are said to be, we call them this way, they are not by nature, are said to be independent from one another. independent. And if this is not true, so if this sign, this equality sign, isn't true at all, in this case, they're not independent, they're dependent on one another. So talk about some wording first. That was that. Events can be exhaustive, events can be mutually exclusive, they can be dependent, they can be independent, and so on and so on. Talking about events first of all. I will take a look at the questions. Maybe we can answer one question already. Yes, like here, question 2. This could be your question. This could be your CFA Level 1 question in the next CFA Level 1 exam, taking place in December, taking place in June, who knows. In regards to probability theory, exhaustive events are also known as events that are mutually exclusive, or that include all potential outcomes, or that have a probability of 0, or probability of 0. I mixed it up here. So what did I want to say? With a probability of 0. That was that. So what would you consider to be true? Exhaustive events. Exhaustive events include every single possible outcome, and that is that. So answer B would be nearest to the true answer. Would be nearest to the true answer. So the answer to level 2, to question 2, excuse me, is and would be B. That is that. Okay, we'll be dealing with question number 1 a bit with base theory later on. Let's take a look at 3. These are probabilities: marginal probability, conditional. We have dealt with the joint probability already. So the joint probability of 2 given events happening at the same time would be called a joint probability, which is question 4, answer C. And okay, now, very good. Question 5, what do you think of question 5? 2 dependent events, they need to be dependent on one another, not independent from one another, but dependent on one another. 2 dependent events have the characteristics of, first, in answer A, the chance of the 2 events occurring is determined by the product of each event's probability. First, answer A, or answer B, the 2 events must happen simultaneously, or C, the chance of one event influences the change of the other event. What do you think is true? What do you think is true? What is nearest to the true answer? Let's take a look first at answer B, the 2 events must happen simultaneously. If we see what is true again here, so 2 events are called independent from one another if the product of the 2 probabilities, P of A times P of B, is equal to the probability of A and B happening at the same time. So yes, independent events, and the probability of 2 independent events is determined already by the multiplication of the 2 probabilities, of the 2 single probabilities. This is true, but this rings a bell. This rings a bell of, wasn't it, with answer B? Let's see here. The 2 events must happen simultaneously. Yes, there is something. So the probability of the 2 events happening simultaneously is given by P of A times P of B. Yes, there was something, but it doesn't have to be that way. So 2 dependent events as well as 2 independent events can happen simultaneously. They don't have to happen simultaneously. It could be true they do, it could be true they don't. So answer B isn't the right answer at all. B is wrong. Let's see how to deal with answer A. What do you think? What do we do with answer A? The chance of the 2 events occurring is determined by the product of each event's probability. No, because This is, let's see it again, the chance of the two events occurring is determined by the product of each event's probability. This is true with independent events. This was just the definition, wasn't it? This was the definition. If we see here again, so the definition says the probability of the two events occurring at the same time is given by the product of the single probability of the single events. Yes. So answer A would be true if we were talking about about two independent events. So answer A is wrong as well. So it has to be answer C, but let's be honest. Let's take a look first and then say whether or not it's true or not. The answer C, the chance of one event influences the change of the other event, is very important. It is true and very important because dependent means one event influences the other, right? That's the true core of the word. So yes, answer C is right. And that was it. 5 is C. If we write it down, so 5 is C. And I think we decided already on question 2, didn't we? Question 2, with regards to probability theory, exhaustive events are also known as including all potential outcomes. So 2 is and was B. Where was it? 2 is B. Great. So if you work your way through all the answers later this webinar, then you will find the answers here. Let's just work our way through all the easy ones first, and then we go to the very, I think, a bit difficult, more difficult at least than all the others, dealing with base formula. So that was 2 and that was 5. Taking a look at 3, we need to talk about probability and the true meaning of probability first. And we'll do that later on. How about 4? The probability of one event, blah, blah. Sorry about that. Marginal probability, conditional probability. Oh yes, we need to understand the meaning of conditional probabilities first. So we go back to our mind map. Mind map, I created those mind maps, like the mind maps all in all, I think it includes more than, see, 200 pages, wasn't it? No, 110. 110 pages for CFA level 1 mind maps. This is, for example, 2018 curriculum. So everything that needs to be known, everything that needs to be understood when it comes to CFA level 1, we got the same thing for level 2. And now we'll be dealing with probability. There is objective probability, there's subjective probability. But we want to want to take a look at conditional ones as well as unconditional probabilities. So unconditional probability, an unconditional probability is this. For example, the probability of having rain this evening. If you take a look outside the window, does it rain? Does it not rain? Is it in the morning? Is it in the afternoon? So the probability that there's going to be rain this evening, this night, is, for example, 0.3, 0.5, I don't know. And it could be an empirical probability, say that you measured rain, you said it was raining the last 10 days, or it was not raining the last 10 days in the evening. So that would be an empirical probability. If you looked outside the window in the evening of the last 10 days and said it was raining or it was not raining, so that would be an empirical probability because you made your statistics, you said whether it was raining or not. That's empirical. That when it comes to the word empirical, that is that. Subjective probability is given by you only because it is very subjective. It is very dependent on the one single person saying so. Like you said, you could say it's raining, and your wife, your husband, or your friend, or anybody says no, it's not, and then you'll have a little dispute over it on whether or not it's raining. So A subjective probability is given by, or your feelings, by your experience on whether it's going to rain or not. Talking about empirical probability, talking about subjective probability. What did I want to say? And an unconditional probability does not depend on any other event. So that's an unconditional probability, the probability of A, unconditional probability. Whereas this A, when B occurred, given that the event B occurred before, is this. That's a conditional probability. Conditional probability, meaning that B has to happen first, and given that B happened first, we now want to conclude and compute the probability of A taking place, having taken place. So the conditional probability of A given B is denoted by this, by A and a slash and a B. So A given B would be a conditional probability. Now that's important. And like, how do we compute both probabilities? The unconditional one, P of A, is this, the number of elements of the set A divided by the number of elements of the set omega. Omega denotes the set of any single event that's possible at all. So, like if you throw a fair dice once and only once, there are 6 possible outcomes if you throw dice, fair dice. Or even an unfair dice, that wouldn't change the number of possible outcomes. So there are 6. There are 6 possible outcomes when you throw, if and when you throw fair dice. And let's say I want to calculate the probability of saying you want to throw a 3. You want to throw the number 3. So the probability of the number 3 would then be 1/6, because omega is composed of 6 elements, 1, 2, 3, 4, 5, 6. And the probability of 3 is like 1/6. So the probability of throwing the number 3 would then be the number of elements of this set divided by the number of elements of that different set that is made up of 1, 2, 3, 4, 5, and 6. That is 1/6, right? That's an unconditional probability because it's not made up of any condition. There is no condition at all. There is not any event happening first. So that's an unconditional probability. And the conditional probability of A given B is this. It's the probability of A and B happening at the same time, AB, divided by P of B, divided by the probability of the event having taken place first. So the event having taken place first needs to be there. That is this. So that's called a conditional. That's called a conditional probability A given B, and make sure the slash is this way, going down, not to the side, not to this side, nor to that side, but just going down in a right angle, as to say so. Now, what did I want to say here? When we take a look at the questions again, what is this? Question 4, question number 4 could be your question. If that was your question in CFA level 1 exam, how would you answer? What would be your answer? The probability of one event occurring given that another event has already occurred is called a marginal probability, is called a conditional probability, or is called a joint probability. Now, Question C is easy because it's wrong, and one can see at a single glance it's wrong. Like a joint probability is A and B happening at the same time, not anything different from that. So C is wrong. It's not the one thing that I described before, like the one event occurring given that another event has already occurred, which is a conditional probability, as one can see very clearly. So B is right, C is wrong, and a marginal probability is just a synonym. It's a synonym for an unconditional probability. So A is an unconditional probability and of course wrong, B is right, and C has to be wrong. So if I gave you the answer in question A, like unconditional, if I wrote unconditional, it would be very clear, it would be too easy, right? If I said conditional and unconditional, that would be the case that, because any probability is either conditional or unconditional, that A or B would be right and C must be wrong. So I had to indicate a different word for it. I had to write a marginal probability, and so I did this because I wanted you to be wrong, right? In our prep courses for level 1, level 2, we always want to like lead the candidates into the wrong direction first, because you need to understand, and you better understand when committing a fault. So that was why I wrote this way. That was question 4. We did question 5. We answered question 2, but we didn't say anything about question 3 so far. So let's go there. Which of the following probability estimates do you think would be significantly different from between people? Like there's one guy, there's one candidate saying this way, and there's another CFA candidate saying something else, something different. Which would be the probability estimate that we think would be most different from one another? And of course, it's the subjective probability, because like your boyfriend, your girlfriend says so, and you, once you dispute with one another, you are totally different. Your standpoint is by far different from the one of your boyfriend or girlfriend. So that's why the subjective probability is, of course, most different and can be most different from one another. This does not hold true for an empirical probability, because different persons could have the same standpoint, could have the same, like they could have done the same testing, they could have done the same empirical observation in the last 10 days. Like if you want to measure the amount of days with rain the last 10 days, and you want to measure the amount of days with rain, one person saw that it was raining on 6 days out of 10, and the other person saw it was raining on 6 days out of 10 at a different place on the same planet, but possible, of course. So they don't have to be different. They could be equal. They could be truly equal. And so B is right and A and C are wrong. So let's get to this question number 1. And question number 1, of course, is the one question that I wanted to do at the end, because it is the most difficult one. We have to fully understand everything that deals with conditional probability, everything that deals with unconditional ones as well. We need to learn base formula and so on and so on. Let's go back to the mind map. Conditional probabilities can be dealt with base formula. We need to see the multiplication rule, and we have to have knowledge about the total probability rule. So let's see here. You have analyzed many companies and noticed there is a relationship between how ethically the CEO behaves and so on. So if the CEO of the company behaves in a non-ethical manner, there's a probability of 35% that the company is going to go bankrupt. It could go bankrupt if the CEO behaves unethically, and of course, it could go bankrupt just as well in the other case, if he or she does not behave unethically. So first, we can see if he or she behaves unethically or not. Meaning that we have a tree. We have a tree, as we call it in statistics and probability theory. First, he or she behaves ethically, and we will denote this event by the letter E. And the complement, the opposite, just the opposite, is given by and is denoted by EC, E to the power of C, if you want to call it this way, or just E complement. Let's better call it E complement, because to the power of does not make very much sense. So what did I say about the probability? Taking a look here, the probability of unethical behavior is 5%. So now, given that the probability of unethical behavior is 5%, it is true, of course, that the probability of ethical behavior is equal to 0.95, right? And I didn't say this, but it's true. Of course it's true. And I want you to know this. It was not necessary to say, like, P of unethical behavior is equal to 0.05. The formula didn't have to be mentioned. It was clear from the beginning, like the probability of unethical behavior is 5%. This totally suffices. This totally suffices. This is just enough for you to be able to get this number and to put it into the formula and to calculate the right answer. So it was very kind from me, and it would be very kind from CFA Institute, by CFA Institute, to say so. They don't have to say so. So that is that. And the probability, so now there's a difference. There's a different level, is at the second level, if the CEO behaves ethically, then the company could go bankrupt. Bankruptcy happen if E happened first, or it could not go bankrupt if E happened first. Those are the two possible outcomes given the event that the CFO did act ethically. So there is a second level now dealing with bankruptcy. And here, the company could go bankrupt if the CEO did not act ethically, in an ethical manner. Bankrupt, or the complement of bankrupt, given that E complement happened first. So that's important. And of course, again, the two add to 1. So the 2 would add to 1. Let's erase this. Meaning, just want to save it so that you can download it later on and see that what we talked about so far. What was the answer? What was the number here? If the CEO of the company behaves in a non-ethical manner, there's a probability of 35% that the company will go bankrupt. So bankruptcy, if there was an unethical behavior, happens with a probability of 0.35. Unethical behavior, and then after this, going bankrupt means that this is 0.35, isn't it? You need to understand now. And remember this, it was necessary for me to put the answer in a formula manner. Without the formula, of course, you should have been able to see this just by the description. 0.35 leading to 0.65 here. The opposite holds true. The opposite holds true with 1 minus 0.35 leading to 0.65. 0.65. Same here. The same here with 0.1. Bankrupt if there is ethical manner. Bankrupt if there is ethical manner, 0.1 and 0.9. That is that. So now, That was the tree. That was the tree. So with the tree, with the help of the tree, it's very easy. Of course, a mathematician would always say it's very easy. I know it's for some it's not, but so don't put too much stress on my words here. If I say it's very easy, it doesn't have to be easy for everybody, and it's not. It's totally true if it's not very easy at all. The probability of going bankrupt, the probability of event B is equal to 1.1125 to 0.1125, excuse me. Answer A. Which of the following answers is not correct? So we need to calculate this answer. What would you say about answer A, the probability of B? And so there's the total probability rule. The total probability rule, let us just talk about this way. Like the unconditional probability of B, of the event B, is asked for, and B is located here, for example. So if we just go here and put it a bit longer, going from the very start to all the spots, all the places where B happens first, this would mean that we go here, ending there, plus we would go there, ending there. Those would be the two ways of where to go to with answer B at the very end. Meaning P of B is equal to P of B if E happened first, multiplied by the probability of this event having happened first, plus the second way, the probability of B again happening if the other event, if the other prerequisite non-E, the complement of E has happened first, multiplied by this prerequisite, multiplied by this thing, that event that could have happened first. So if we underline it with a different color, I want to know something about B, so I go to there, I go to both places where B happens first, and not non-B, but B, and all the way up, all the way to those places, meaning that we take a look at every single event that could have happened first, once we go there, once we go to the event B. That's called the total probability rule. The total probability rule here, the total probability rule dealing with conditional probabilities, and I mean, it deals with conditional probabilities. It leads to an unconditional probability, but it deals with conditional ones. So the total probability rule is the answer, or is the tool to give the answer, meaning that it is 0.1 multiplied by 0.95 plus 0.35 multiplied by 0.05. What is this? This, of course, I hope you have a handheld computer. 0.1 times 0.95, of course, it could have done this without any computer. 0.35 times 0.05 is 0.0175 plus the one that we computed before, leading to 0.1125. Isn't that cute? Isn't that a cute answer? It is, you will say. It truly is. So the answer A is a true answer, and let's see here what I asked for. I asked for a non-correct answer. So since it's correct, it's non-correct. Can you tell the difference? Yes, you can, because it's Since it's correct, since it's a correct answer, it is not a correct answer because I asked for a non-correct answer, meaning I don't have to put a cross. I don't have to say that answer A was correct because it was correct. Yes, I know you're, it's kind of tricky to really follow this up. So answer A is wrong. Talking about answer B. The probability of unethical behavior is if there is bankruptcy, if bankruptcy happened before, which is like kind of strange to ask this way because like what has happened first was the ethical and non-ethical behavior. Now we are asking the different direction, but you were able to answer. You were able to answer this now. And what was the question again? It was this unethical behavior happening first. So E complement happening first, given the case that bankruptcy happened before. EC if B happened before. Let's keep that in mind. Probability of EC if B happened before. Let's be very careful about this. The line needs to be that way, not that way or that way. That would be very wrong, as well as this, but that way, yes. Okay, cool. And now, if we're talking about, if we're asking for something that's already given, but given the other way around, it's a case and it's a situation in which we would make use of Bayes' formula. And we'll do this here. Bayes' formula says we change the ways, like B given EC, the complement of E, multiplied by the event being in front, dividing by the event being at the end, And so now, this is important. This here is the answer 0.1125, right? So the total probability rule is already part of the answer. That's why we're talking about, that's why we're asking for the total probability rule first, and then go to Bayes' formula, because Bayes' formula makes use of the total probability rule. That's important. Keep that in mind, please. Bayes' formula makes use of the total probability rule. Leading to this answer, leading to those numbers, the probability of B, if EC happened first, if E complement happened first, is given by 0.35 multiplied by the probability of the event EC, 0.05, divided by 0.1125. And this is, I calculated it somewhere, but I can't find it anymore. So let's just do it here. 0.35 times 0.05 is 0.0175 divided by 0.1125, which is 0.0175 divided by 0.35 times 0.05, blotch. So here, yeah, okay, cool. And of course, we need to round it. So 0.156. Let's just round it this way, meaning that the answer B is a correct one, is a correct answer, because 0.156 is a correct answer. And since I asked for an incorrect answer, it is, again, you have to like twist your brain a little bit. It's a what was it? It's a non-correct answer. It's a false answer because it's a right answer. Do you get what I want to say? Yes, you do. So we don't put a cross there. Answer B is not correct because it is correct. Let's take a look at C. B and A are mutually independent variables, and let us just, if you could just correct the A to an E. B and E, like bankruptcy and unethical or ethical behavior. Bankruptcy and ethical behavior are mutually independent variables. Now we can just compute this. So B and E, the probability of B and E, the probability of B and E happening at the same time can be computed somehow. And of course, the probability of B multiplied by the probability of E can be computed as well, which is easier. So let's do it first. The probability of B is given by 0.1125, which we computed in answer A. Now the probability of E is 0.95, as we can see up here, 0.95, which is 0.1125 times 0.95, which is 0.106875, right? Yes, that is that. Now, the multiplication rule. The multiplication rule goes this way. P of A and B at the same time is given by A if B occurred first times the probability of B. That is the multiplication rule, because you can understand it a bit better, a bit easier if you say the conditional probability of A given B is defined by A and B divided by P of B. So that's why the multiplication rule always holds. Multiplication rule. That's the multiplication rule. And yes, so now that is the probability of B given that E occurred first multiplied by the probability of E would be B given A 0.1. 0.1, where was the answer? 0.1 multiplied by P of E, which was 0.95. And now hold your breath, because I mean, C has to be true, so C has to be wrong, if you know what I mean. So this is why we have to hold our breath, right? Because the result of 0.1 times 0.95 is 0.095, which is not the right answer, which is not the same result. So they have to be unequal. They need to be unequal because we have to get the right answer, which is a wrong answer, right? Which means that B and E are dependent. B and E are said to be dependent. They are not independent, they are dependent, which means the one thing influences the other one. There's like the person, the CEO, behaving unethically changes the case of bankruptcy happening into the direction that it could easier go bankrupt, that the company could easier go bankrupt. It could also be true the other way around, but here it's constructed this way, that it goes bankrupt easier than if it was true the other way around. B and E are dependent, and so the answer was what again? The answer was B and E are mutually independent variables, which is wrong. So this is the right answer, if you know what I mean, because I asked for which of the following answers is not correct, right? So one is C. One is C. Answer C is the right answer. One is C. And 1, 2, 3, and 4. Let's just go here again and see what we said to question 2. In question 3, we said B is correct. 3 is B. And 4 is, what was it? I always, of course I forgot it. 4 is the probability of an event occurring given that another event has already occurred. Of course, it's a conditional one, so B is correct, and we're asking for which of the following answers is correct, and not which of the following answers is not correct. First of all, in your CFA Level 1 exam, and of course the CFA Level 2 exam, you first need to take a look at the question. Does the question go this way, which of the following answers is true, or does it go the opposite way, like which of the following answers is not true? Like, that's important first of all. So that was that. Thank you for having watched. Thank you for having listened. I'm going to do 4 other webinars the next days, and those are, there's one on Friday this week. There's one on Friday this week dealing with economics. We'll be talking about restrictions of free trade. And that are tariffs, that are subsidies, that are quotas, import quotas. And so we'll be dealing with the pros and cons of trade. Is there an advantage of trade? And yes, there is. We'll see that there is many more advantages than disadvantages to free trade, to free international trade. This is going to happen this week, and then next week we'll be dealing with financial reporting and analysis, and of course equity next week, and derivatives. So everything, some very important aspects. I think we'll be dealing with the binomial tree. Yes, the binomial tree when it comes to derivatives. So many very important things, and I would like you to follow. Please just send an email, just enroll via email if you want to participate in those other 3 webinars. And of course, there's a webinar shortly before the CFA Level 1 exam. There's a webinar that stretches among 5 different days. So 5 different days, 6 hours in a single day, and everything that deals with CFA Level 1 will be dealt with. We'll be dealing with everything you need to know, everything you need to understand. And yeah, thanks for watching. Thanks for listening. I'm Daniel Lambert, Berlin.